Okay, today we're going to talk about absolute value inequalities. This is 1.7 day 2. How many solutions are you looking for with an absolute value situation? That's 2 solutions. We talked about that in the previous video. This is your to-do list. Isolate the absolute value and write your 2 inequalities. When you write your 2 inequalities, you need to flip the sign for the negative version. Then you solve them and write them in interval notation, and we'll practice that. Okay, here's your first one. The absolute value bars are already isolated for you, so you're going to write the 2 situations down. And then for the second one, you're going to flip the sign because you're solving for a negative value. So here I'm going to add 1 to each side. I'm going to add 1 here. So now when I graph these, I'm going to have a compound inequality. Absolute value inequalities always become compound inequalities. So let me start with -2 on this end. Went a little crazy. All right, my dot is closed in. All the values that are less than are to the left. Here's my other end, which is 4, closed in because it's or equal to. Here are all the values that are greater than or equal to. Now let's work on that interval notation. Let's start to the far left. That's negative infinity. So you get a parentheses, and it stops at -2, so you're going to bracket it. Use our symbol for an and. I'm going to use a bracket here because 4 is colored in. And then infinity gets a parentheses. Let me write that better. There you go. All right, the next one is the absolute value of 4x is less than or equal to 20. Absolute value bars are already isolated. So we have 2 scenarios here. Flip the sign for the negative version. I'm going to divide by 4 on each of them. Okay, so let's make a graph of this one. Have opposites here, so you have -5. Again, this is or equal to, so we're going to color in, fill in, and this is an and your interval notation filled in this way, -5 on that end, 5 on that end, brackets because they're or equal to. Next one, again, our absolute value bars are already isolated, so we don't have any work up front like that. So we're going to write it 2 ways. Flipping the sign for the negative version. Add 2 to each side. So I have 3x is greater than 9. Divide by 3, x is greater than 9. I'm going to add 2 to each side here. So this time I have 3x is less than -5. When I divide by 3, I have x is less than -5. Yes, you can graph fractions, and I'm going to show you how. So let me change the pen. Oh, look at that. It came out just right. So let's graph x is less than 5/3, negative 5/3. So that's really negative 1 1/3, which is right here. It'll be open, and the numbers that are less than are to the left, and then greater than 9, like that. Okay, so we have negative infinity at the far left, and we have negative 5/3, but it's open, so you use a parentheses. You have 9 here, and infinity. Oh, actually, this should be 3. Sorry, folks. This should be 3. So let's do this. I didn't do the division. So let me change this to 3. There you go. Sorry about that. And this should not be 9. It should be 3. There you go. All right. I have, I think, one more like this, and we need to do some work on this one. So we have the absolute value of x plus 2 minus 3 is less than 7. First, we got to isolate by adding 3 to each side. So then we have the absolute value of x plus 2 is less than 10. So now we can have our two situations. Flipping the sign with the negative version. So I have x is less than 8 over here. And after I subtract 2, I have x is greater than negative 12. All right. Yeah, this is going to take some couple intervals, and I think they're both even, so I'm going to go by 2s. See if we can get them in. On this end, I have negative 12, negative 10, negative 8, 4, negative 2, 0, 2, 4, 6, 8, 10, 12, 14. Okay, so I have x is less than 8. So open, and we go that way. And x is greater than 12, so this is an and, which makes our interval notation negative 12 and an 8. They're parentheses because the ends are open. Okay, we have a couple more things to do. We're going to write absolute value inequalities from graphs. And here's the steps you take. You need to find the midpoint, write it as an opposite in absolute value, and then you set it equal to the distance between the original points and the midpoint. So let me show you how this is done. So the midpoint between 2 and 6, that's halfway between, let me get white ink. That's 4, right? So I am going to set that the opposite of 4 is negative 4, so that goes in your absolute value bars. So this is an OR, and the ends are open. So I'm going to make that greater than sign because it's an OR. ORs are greater than, or greater than or equal to, ands are less than or less than or equal to. And then if you go from an end to the midpoint, so if you go from 2 to 4, that is 2. So distance to the midpoint is 2. So there's your absolute value inequality. Let's look at the next one. This is an and. So your midpoint here, halfway between, is 4, positive 4. And then your distance from either end to that midpoint is 8. So opposite of that 4, so x, the absolute value of x minus 4, and this is an and it's filled in, so less than or equal to 8, because that's the distance to the midpoint. One more. We have 11 and 3. So the midpoint halfway between negative 11 and 3 is negative 7. So if you go from negative 11 to 7 or negative 3 back to 7, the distance to the midpoint is 4. So let's set this up. We're going to do opposite inside the absolute value bar. So opposite of negative 7 is 7. And this is an and, so it's less than because the ends are open, and the distance to the midpoint is 4. All right, that's it for today.